Let us now discuss about scatter diagram. Scatter diagram is a plot which represents the relationship between two variables. What does this mean? Let us first try to understand using some basic examples, post which we'll come back to the slide and do a deep dive. Let me select a pen here. Say there is a shopping mall owner. He comes to you and says that now that you know Tableau, now that you know statistics, can you help me analyze and come up with strategies on promoting the sales in the shopping mall or increasing the number of footfalls in the shopping mall? You would say, all right, let me do this. And you try out this. You try to plot the time spent in the shopping mall on the x-axis and you would say, let me say 1 hour of shopping, 2 hours, 3 hours, 4 hours, 5 hours, so on and so forth. So let me put it down. 1 hours, 2 hours, 3 hours, 4 and 5 hours. That's the time spent in hours. And also on the y-axis, you try to plot the amount spent by the various customers. I'll mention it as $50, $100, $150, $200, and $250. Now we will start plotting. So let me select a different color there. All right. Say there is a bachelor or spinster. If they go to shopping, this is what happens. Say for the first hour that they spend shopping, they purchase products worth $50. If they tend to spend 2 hours, probably this time they would do some kind of window shopping there and not increase or do not purchase anything more. Third hour, probably they'll be spending time checking out the latest gadgets but not purchasing those. If they spend 4 hours in a shopping mall, probably in the fourth hour they'll be checking out who is entering the shopping mall, who is beautiful and who is not, and things in those lines. And fifth hour, since they have no other work, probably they get bored at home, so they just sit, relax in the shopping mall. So if you see this kind of a trend, we can straight away say that there is no correlation between the time spent and the amount spent. So this kind of a correlation is called as no correlation. So you can safely say that there is no correlation between the time spent and the amount spent by the bachelors or spinsters in the shopping mall. Let me see whether I can erase only a portion of this. Or do we need to erase everything? I believe we need to erase everything. Okay. All right. That's no correlation example. Now let me give you an example of the same shopping mall. So your shopping mall owner would say, hey, so what strategy do I need to devise? Probably you'll say that, hey, do not come up with any offer for bachelors or spinsters because they would just come in, spend some time and go away. So you would now switch gears to a different segment of people. And you would say, okay, let me now do this analysis for married couple. So once again, the time spent on x-axis and the amount spent on y-axis is what you're trying to plot. 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours. $50, $100, $150, 200 and $250. For 1 hour spent, if you especially go with your spouse, if your wife, right? If you go with your wife to a shopping mall, if you spend 1 hour, you tend to spend $50. Assume that this is the data. For 2 hours, you would be spending $100. For 3 hours, you would be spending $150. For 4 hours, you'd be spending $200. For 5 hours, you'll be spending $250. And if you continue to spend, you'll go bankrupt. All right. So if you notice this kind of a trend, wherein you see an upward trend, that is, as in how the time spent in the shopping mall increases, if the amount spent also increases, then this is called as positive correlation. This is called as positive correlation. All right. Now, let me explain you about negative correlation. I'll take a different example. Say you went to a doctor and you told that you're not keeping well. So, doctor would say, "Hey, recently I've read an article which says this." And what is that article all about? And what does it say? On the x-axis, they have plotted life expectancy of male. And on the y-axis, you have years of marriage. By now, you should have, I'm pretty sure you're guessing it now. Okay, so, or let me swap these two. I think if I swap these two, it makes more sense. So, oh, my bad. Once again, let me select the blue color of the sign. So you have the x-axis and y-axis. On the x-axis, I'm going to plot years of marriage. And on the y-axis, I'm going to plot life expectancy of male. So 1 year of marriage, 2 years of marriage, 3 years of marriage, 4 years of marriage, 5 years of marriage, so on and so forth. And here you have 100 years and 90 years, 80 years, 70, 60, 50, so on and so forth. If you're married since 1 year, probably you can expect to stay alive for maybe 100 years also. If your marriage extends to 2 years, that means there'll be a lot of burden on you, especially male community. The, the age would drop to 90 years expectancy. If you continue your marriage for 3 years, you would live not more than 80 years. If it's 4 years, 70 years. If it's 5 years, 60 years. If it's 6 years. And you know what would happen if you continue to lead a married life, right? Jokes apart, with all due respect to the women. This is just to bring in the humor to explain the concept. All right. So if you see this kind of a trend, a negative trend, that is, as and how the years of marriage increases, your life expectancy would decrease. If you notice this kind of a trend, it is called as negative correlation. It is called as negative correlation. All right, let me go back. Now it should make sense for you all. So if you see a positive direction, it's called as positive correlation. Here also it's positive correlation. Here it's called as no correlation. Here there is a negative correlation. Here there is a negative correlation because it's in the downward direction. Now we can also measure the strength of the relationship. If you draw a straight line like that, and if the data points are close to this line, it's called a strong positive correlation because it's in the positive direction. If the data points are not so close to this line, but kind of okay, it's called as moderate positive correlation. If I draw a straight line in that way, and if all the data points are closer to this line, it is called a strong negative correlation. And if I draw a straight line in that way, and if the data points are slightly dispersed along the line, it's called as moderate. As and how the data points go far away from the straight line that you've drawn, you call this relationship as weak relationship. So you can understand the direction of the relationship and strength of the correlation using scatter plot. One more thing that we can understand using scatter plot is linearity. Linearity. Linear means a straight line. Linear means a straight line. And remember just one small point. If at all the relationship is linear, only then we can build prediction models using linear regression. We'll discuss that later on. So linear regression, etc., we will discuss later on because that is pretty much part of your Tableau analytics part. So we'll get to that later on. Now look at this here. You see that it's a curvilinear. It appears as if it's a curvilinear relationship, right? And if you have this kind of a representation, we cannot go with a linear regression directly. We need to do something else, and what is that something else we'll discuss in a moment from now. Now, two things here. One is the strength of a correlation is very subjective in nature. A few of you all might say that these data points that are here in this particular plot also seem to be strong negative correlation maybe. A few of y'all might say, hey, that's a weak negative correlation. So there is always an element of subjectivity when it comes to the strength of the correlation between two variables. And we'll discuss on how to crack it statistically using something called as correlation coefficient, which is represented using small r. We'll discuss that in a moment from now. Before that, let me explain you all on the difference between correlation and causation. For this, I need to give you a small example here. So, a few years back, a magazine has given this, plotted this, right? And it has plotted ice cream sales versus shark attacks. So when they have done this analysis, they have felt that as in how the ice cream sales increase, the number of shark attacks were also increasing. Now, does this mean that ice cream sales, just because you're eating ice cream, sharks are attacking you? Can we say that? Can I make the statement that since you are eating more ice creams, more sharks are attacking you? It would be such a weird statement to make, right? It would be such a weird statement to make. This is absolutely wrong statement. Just because there is a correlation, positive correlation between ice cream sales and shark attacks, does not mean one is causing another. Ice cream, you eating ice cream is not causing shark to attack you, or shark is attacking you and hence you're eating ice cream. Neither way, it would hold good. Hence, causation is different, correlation is different. If this statement was true, this would have been a causation statement, meaning ice cream sales is causing shark attacks, or shark attacks is causing the ice cream sales increase. But here we see that there is a positive correlation. That's it. So that is the difference between your correlation and causation.